Okay, so the topic is induced electric field, and if you can guide me what to talk about, that will be very nice. But I can also start on this. So this is all related to that Faraday's law of induction, right? So Faraday's law of induction has two parts, or Faraday's law is what E is minus d phi dt, right? Now that d phi dt can come from change in change in flux. D phi dt is change in flux, right? Very good. But first let me talk of what is this EMF business. Let's talk of this EMF. What is EMF? Let's take views. What is EMF? Yeah. So how do you? What is that? What is that quantity? That is all right. Maximum voltage when the circuit. So is it a voltage? Is it a potential difference?
When
EMF.
No current is
Okay. It is electrostatic force. Electromotive force. To accelerate the electrons.
work done
Okay.
by the battery.
Amount of work done.
By the battery.
Who does the work?
Battery.
Which force? No, work is done by a force. Which force?
Because of the potential difference between the two cells, the energy is stored there.
Where is the force? See, when you talk of work, there should be a force, there should be a displacement.
Electrostatic force.
When you talk of work, there should be a force, there should be a displacement. Then only you have work.
Between two plates of battery, there is a electrostatic force between two cell plates of the battery.
Because of the electric field,
Because of the electric field.
Negative plates say
Okay.
electrons.
Electrolytes.
Because of the electrolyte, there
Ah.
is a source of potential difference which is driving the electron chemical.
So where is that force? Which is that force? Responsible for EMF. You were saying something? It is the potential difference when no current flows. Okay. Okay. See, the electric field, if you think of battery and you have electrodes and all that, and then there is a positive charge appearing here, negative charge appearing here, is part of the battery. You have a positive terminal, you have a negative terminal. If you connect a wire, etc., there will be a current driven. Now, yes, there is an electric field. If you have positive charges here, negative charges here, you do have an electric field. But what this electric field will do, in which direction the positive charge and in which direction the negative charge will move because of this? Electrons, which direction it will move?
ये
Electrons.
प्लस टू माइनस नहीं गलत हो गया इलेक्ट्रॉन्स will move from negative नहीं हाँ negative में
The electric field is always from plus charges to minus charges, and the force on the electron is negative, so it should go towards positive.
Inside we have ions, electrolyte is
Ions,
are
ठीक.
going to move, are going to the respective electrode.
ठीक, क्यों? कौन ले जाता है? कौन ले जाता है? If you have positive ions, वो positive ion, where will it go under this electric field?
Repulsion.
It's going to the negative plate. It's going to the negative plate. ये उल्टा कर रहा है ये. It's not separating the charge. Electric field will never separate the charge.
Can I have some clarity sir please? ये जो आप बोल रहे हैं सर ये पॉजिटिव प्लेट है वो नेगेटिव है तो फील्ड का डायरेक्शन उधर है तो इलेक्ट्रॉन जो मूव कर रहा है दैट इज मूविंग फ्रॉम नेगेटिव टू पॉजिटिव
Force of repulsion.
तो इक्वलाइज कर देगा, न्यूट्रलाइज कर देगा, आपकी बैटरी खत्म.
यहाँ पे इलेक्ट्रॉन उसी डायरेक्शन में move करेगा.
Chemical elements are doing work inside. So if you have a battery, right, if you have a battery, then only you talk of EMF. If you have a capacitor plates, positive charges and negative charges, you don't talk of EMF. Right? You talk of potential difference. You talk of the voltage Q by V, Q equal to C by V वगैरह वगैरह करते हो. EMF नहीं बोलते वहाँ पे. बैटरी होती है तो EMF बोलते हो.
कोई इलेक्ट्रोलाइट का जो पोजीशन होता है, रेजिस्टेंस होता है, जो इलेक्ट्रोलाइट मोमेंट में, आयंस के मोमेंट में.
So there is something in the battery which is exerting force on the charges opposite to the electric field. There is something in the battery which is sending these positive charges to that positive plate or positive terminal, negative charges to the negative terminal. Even if you connect it, and this because of this connection, because of the circuit, electrons are withdrawn from here and electrons are sent on this positive plate. Even if you are sending the electrons here, trying to neutralize this plus, there is something which maintains. No, this much positive should be there, this much negative should be there. It is 1.5 volt, it should be 1.5 volt. This has to be positive, this has to be negative. So something is there which is maintaining that 1.5 volt by separating the charges, by pushing the positive charge this side and negative charge this side. The electric field will not do that. The electric field will not do that. The electric field, because of these plates, will push these positive charges towards this negative plate, and that will immediately destroy your potential difference. It will get neutralized. 1.5 will suddenly become 1.2, 0.20. So there is some force on this positive charges and negative charges which is opposite to the electric field forces. That force has to be understood, identified, and it is that force which is doing the work. It is that, it's not electrostatic force. It is a driving force. You can call it driving force. It drives. It separates charges. The positive charges go on one side, the negative charges go on other side. Because of that, an electric field is produced, and that electric field will try to neutralize that, right? But then in presence of that non-electrostatic force which is there, because of some reason, the separation is maintained. Even if you withdraw some electrons from the negative plate, even if you deposit those electrons on the positive plates, even then the separation is that much separation, that much plus Q, that much minus Q is maintained, that much 1.5 volt or 2 volts or 6 volts is maintained. Okay? So it is this driving force which defines EMF. In capacitor you don't have that. In capacitor you don't have that mechanism, and therefore if you connect the two plates using an external wire, it discharges. You talk of time constant, this, that, it discharges, right? But battery maintains as long as that driving force is present. What is the origin of driving force? So for that people are doing all kinds of researches, right? That chemistry which is going on, that half oxidation cell and blah 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 blah. So from there you are generating forces which are separating it, right?
Chemical reaction taking part in that.
Right. So and when those chemical reactions are not taking place because the chemicals have been destroyed, used up, this, that, your battery get discharged. Then you are not able to maintain that.
That's why this driving force should be greater than the electric field.
Should be equal to. If it is greater than more, and 1.5 will become 1.6, 1.7, 1.8. If the battery is maintaining a constant potential difference, that means a fixed charge separation is there.
So that's E जो हमने mark किया है
हाँ.
plates की polarity की वजह से ये V define नहीं करेगा.
ये हाँ
V define नहीं करेगा.
नहीं ये करेगा, because as you said,
Equal है ना तो.
because the finally the two forces should become equal. If the driving force is more than the electrostatic force, then you have more and more charges appearing on the plates, the battery voltage will go up. If the driving force is weaker and the electric वो उल्टा हो जाएगा, then it will go down. So if the battery is maintaining a particular potential difference, that means this electric field which is inside and the driving force which is there, they should have equal magnitude. And therefore in magnitude, if you calculate work done by this driving force or work done by this electric field force, in magnitude they will be equal. तो इसीलिए वो चल जाता है काम, कहते हैं ना कि आप इलेक्ट्रिक फील्ड से आप पोटेंशियल डिफरेंस निकालते हो, इलेक्ट्रिक फील्ड से आप पोटेंशियल डिफरेंस निकालते हो, E डॉट डी एस डी एक्स डी एल जो भी लिखते हैं, तो आप पोटेंशियल डिफरेंस के टर्म्स में EMF बोल देते हैं, जब ओपन सर्किट है, ये है, वो है, देन द वोल्टेज दैट अपीयर्स इज EMF. Yes, because in that case in equilibrium the two forces have equal magnitude. But EMF is not because of this electric field, EMF is because of the driving force which is separate. और उसके लिए आपको mechanisms करने हैं.
Is there somewhere written what you are saying, so that we can, after this workshop, we can, read more about it? Because it's very interesting. I am coming to know this fact for the first time. So now मुझे लग रहा है कि और मुझे
Same
करना
here,
है.
sir. When you taught us in
Ah.
1993, you didn't taught me that like that.
This was secret for us, okay?
No, 23
Because we
years.
never
Yeah,
learned
23 years before I have a student of him in Patna and doing so much things I am staying doing this type of thing.
23 years में मैंने भी तो सीखा है ना सर. 23 years पहले शायद मुझे भी पता नहीं होगा.
तो तब सर ने नहीं कहा था, जैसे मुझे आज बहुत वो लग रहा है कि कैसे वो चीज़ हो सकती है, क्योंकि तब उन्होंने यही चीज़ कहा था जो अभी हम सब कह रहे हैं. So that is the main thing. Thank you so much, sir.
Okay, now आप पूछ रहे हो ना कि कहाँ से ये हम लाए, तो there are अब हम Faraday's law पर आने की कोशिश कर रहे हैं. अगर आपके पास में एक रीजन के अंदर में you have magnetic field, and then you have a rod, metal rod, which is moving with some velocity v, right? So the free electrons which are there in this metal, they experience the force which is Q into V cross B. As the whole rod is moving, all these electrons are also moving, so they have the same velocity v. Then Q V cross B, this much of force is exerted, and remember this is not electrostatic force, right? And what this force will do, V cross B, so this is V and that is B, so V cross B will be up, because of minus it will be down. So the electrons will go at this end, right, and the leftover things will be positive. Now that the charges are separated, see the charges are separated, electric field will never separate the charges. So this is the driving force. This is the driving force. It is separating the charge. It's putting plus on one side, minus on the other side. And because of this, the electric field is produced inside the rod. Okay? Because of this charge separation, you have plus charges here, you have minus charges here, there is an electric field here. And this electric field is opposing that driving force. The electrons will try to go up because of this electric field, and therefore electrons should go here and this should come down. So once a particular charge separation is created, a particular electric field strength is created, then the driving force and the force because of this electric field, they become equal in magnitude, right? They become, and then further charge separation does not take place, right? So if you have electric field, the force because of the electric field will be Q times E. So direction we have already seen that they are in opposite directions. So when this E times E is equal to E times VB, then the charge separation will be matured, stabilized, correct. So with this VB it will continue, electric field equal to V into B, the rod will continue, this much charge separation will be there. And now you can talk of potential difference, because you have an electric field, corresponding to electric field you can talk of potential difference, and that potential difference is E times the length, E times the length, and that is VBL. So this much potential difference is appearing here. It's like a battery. Yet there is a driving force, there is an electric field, there is a potential difference. Open circuit, this potential difference is same as EMF, correct. If you connect it to some kind of a resistance, and the current will flow. Current will flow means the electrons will go from here, right. This is positive, this is negative, so current is going this way. Electrons are going from here. So electrons are, number of electrons are trying to reduce. Then the driving force comes up, supplies more electrons, right. If the electrons are reaching here, so the driving force is pushing it away from here. So that positive, that negative is maintained. This is the driving force.
It
in
means
this.
to separate the charges, driving force is required, and because of the separation of charges, electric field is
Correct.
So driving force का वो है effect
Correct.
electric field.
Maintaining the equilibrium
Electric
principle.
field की वजह से नहीं होता।
Yes. Correct. In the case of battery. Yes, in the case of battery, because of whatever chemical potential difference between this cell, this half cell, that half cell, forces.
Electrons are neutral.
हाँ
And put them electrodes inside the chemical
हाँ
reaction section.
हाँ
Very double.
अरे वही तो आप केमिस्ट्री उतनी मुझे नहीं आती है ना सर.
That's what sir is saying, chemical reaction and
हाँ मैं तो एक ब्रॉड वर्ड के अंदर समेट देना चाहता हूँ कि हाँ वेराइटीज ऑफ केमिस्ट्री दैट इज गोइंग ऑन. इजी वो कोई भी केमिकल रख देने से तो नहीं होता है. स्पेशलाइज केमिस्ट्री होगी, केमिकल्स होंगे, उसके बाद उसमें भी वो सेपरेशन होता है और क्या क्या होता है, उनके केमिकल पोटेंशियल्स डिफरेंट होते हैं.
ये जो चीज़ आपने बताई कि इलेक्ट्रिक फील्ड जो प्रोड्यूस होता है, जो मतलब डिफरेंस, दिस इज वेरी इंपॉर्टेंट, इट्स नॉट अ कॉज ऑफ ड्राइविंग फोर्स, वो
No,
अलग
no,
चीज़ है.
वो उसका उल्टा है राधा.
सेल में ड्राइविंग फोर्स इज अ सर व्हाट आई अंडरस्टूड इज ड्राइविंग फोर्स इन सेल आई एम सेइंग is a different thing, and field is created because of accumulation of charge is
Correct.
totally different.
Right. Correct.
First time we are
accumulation of charges नहीं हो रहा है।
वो
Driving force
driving
effect.
force की बताई
Yes.
सर, ये सब not driving
Right.
force.
Right.
वही मैं कह रही थी।
Correct.
चार्ज सेपरेशन ही ड्राइविंग फोर्स की वजह
So
से।
sad we didn't know this.
So in the second
You should be happy that now you know it.
Sir, it means there is a workshop required for chemistry and physics teachers together.
ये हमने कंपार्टमेंटलाइजेशन किया है. नेचर हैज नॉट कंपार्टमेंटलाइज दिस. ये फिजिक्स है और ये केमिस्ट्री है. ये हमने कर दिया कि चूज कर लो ऑनर्स किस में लेना है, फिजिक्स में लेना है कि केमिस्ट्री में लेना है. फिजिक्स में करना है तो फिजिक्स पढ़ना, केमिस्ट्री मत पढ़ना, केमिस्ट्री में ऑनर्स करना है तो केमिस्ट्री पढ़ना, फिजिक्स. ये हमारा क्या हुआ है, प्रकृति को इससे कोई मतलब नहीं है. ओके. Alright. So before going to Faraday's laws, E is equal to minus d by dt, we should first be very clear about what is this E, what is this EMF, and we need a driving force, and from where that driving force comes. तो सेल के अंदर में तो केमिस्ट्री से होता है, लेकिन ये दिस वी अंडरस्टैंड वेरी इजीली कि मोशन के कारण, एंड दैट इज व्हाई द नेम इज मोशनल EMF. इट्स कॉल्ड मोशनल EMF. Because it is because of the motion of this conductor in a magnetic field, right? Now the second scenario is that if you have a magnetic field, and you have a circuit, you have a coil, you have a loop, and the magnetic field changes with time. Then also you say that okay, your flux is B into area. Now the area is fixed and d phi dt is dB dt times area. So the flux is changing with time. There is an EMF and there is a current. Right? There is a current I. So where is the EMF now? What drives the current? What drives the current? Initially this was everything is at rest, so there are no velocities involved. So the magnetic field is there, but magnetic field will not exert any force. Change in magnetic field. Yeah, complete the sentence. Change in magnetic field. क्रिया भी तो लगाओ साथ में.
Can we say
वर्ब लगाओ साथ में. Change in magnetic field with respect to time. अभी भी वर्ब नहीं आया है. सेंटेंस तो पूरा तभी होगा ना जब वर्ब आएगा. Changes the flux. That's fine. But my question is, what is driving this current? Where is the driving force? Force चाहिए ना मुझे जो कि force लगाए electrons के ऊपर. You have free electrons in that wire loop, but these free electrons should move. Something should be drive. Something should drive them. In the case of rod moving, we said okay, this is the magnetic Q V cross B which is driving. Here also there should be a force which is driving these electrons. So what force is driving these electrons? The flux is changing, or everything is doing, but let's answer this question. Let's understand this question. There should be a force on the electron. If the electrons are going anti-clockwise direction, then on this electron, okay, on this electron there should be a force in this direction. On this electron there should be a force in this direction. On this electron there should be a force in this direction. And this force cannot be magnetic, because to start with there was no velocity, and without velocity magnetic forces will not operate.
But if you are changing the
magnetic field gives rise to a time varying electric field.
It-
So therefore we have an electric field.
You have an electric field, and that electric field is exerting the force, and that is driving the current. Right, sir? So this electric field, remember, the changes, so this is new physics now. Changing magnetic field creates an electric field, and that electric field drives the current. Okay, that is a driving force, although it is electric field. This is different from the electric fields which was created because of the charge separation. There it was against driving. The driving force wanted current to go this way, and this inside the battery or inside that plates in the space, or even in the rod moving in magnetic field, the electric field was trying to oppose it. Here the electric field itself is driving the current.
change of
So this is a totally different kind of electric field. The electric field that we had talked in when we were talking of motional EMF, or when a battery circuit, that electric field was created due to charge accumulation. That electric field was created due to charge accumulation, and that was opposing the current, right? But this is an electric field which has not come from the charges. It has not come from the charge. It's not that charges are accumulated, plus charge here, minus charge here, and therefore an electric field is created. No. It has, this electric field is created because of the changing magnetic field. Whenever magnetic field changes, it creates electric field. So it's a totally different kind of electric field. That electric field was not driving the current. This electric field is driving the current. That electric field was opposing the driving force. This electric field itself is the driving force. Electron charge multiplied by that E is itself is, so that field and this field, they are electric field. F equal to Q times E is very much valid for that electric field and this electric field, right? But still the two characters are very, very different, right?
So sir, EMF is not defined for this.
EMF is very much defined, potential difference is not defined. This is the driving force. EMF is related to the driving force. Work done by the driving force per unit charge is EMF. Potential difference, which is E times dl, जो हम करते हैं, that you cannot do because if I take a circle, for example, in this, let us take a circle, and let's ask what is the direction of the electric field here. The field is along the tangent. Right? Field is along the tangent. है ना? और किधर लाओगे? और कोई डायरेक्शन ही नहीं है. अब इस डायरेक्शन में या उस डायरेक्शन में उसमें बहस हो सकती है. Tangent in this direction or tangent in that direction. But this is the direction. So now if I do E dot dl, आपको पता है ना, dV is minus E dl. This is how we define potential difference. This is the potential difference. So if you go along the electric field, potential difference decreases or increases. If you go along the capacitor, socho, you have positive plate here, you have negative plate here, you have an electric field. If you go along the electric field, potential decreases or increases? Decreases. Whenever you go, आप Kirchhoff loop law लगाते हो, सब कुछ करते हो, तो आप करंट के डायरेक्शन में जाते हो तो कहते हो कि पोटेंशियल डिक्रीज हो गया, R into I. करंट का जो डायरेक्शन है वही अंदर में इलेक्ट्रिक फील्ड का डायरेक्शन है. So whenever you go in the direction of electric field, potential will decrease. You say E is minus dV by dx and all that. Now from here I am going along the electric field. घट गया potential. तो यहाँ से यहाँ में कम है potential. Then I go on this segment. और घट गया. I go on this segment. I am going along the electric field. It's decreasing. मैं उसी पॉइंट से जितनी बार गुजरता हूँ पता चलता है वो कम हो गया. उसी पॉइंट पर अभी पोटेंशियल इतना था और मैं अगर न घूमता, मैं तो अपने मन में घूम रहा हूँ ना, मैं तो उसको कुछ कर नहीं रहा हूँ, मैं तो अपने मन में केवल घूम रहा हूँ. जितनी बार मैं घूमता हूँ उतनी बार उसका पोटेंशियल घटता जाता है. ऐसा तो कोई पैरामीटर हम नहीं डिफाइन कर सकते ना. एक ही पॉइंट के ऊपर मैंने 2 बार घूम लिया, आपने 3 बार घूम लिया, तो आप कहोगे उतना पोटेंशियल हो गया, मैं कहूँगा उतना पोटेंशियल हो गया. कोई घुमा ही नहीं, वो कहेगा इतना पोटेंशियल हो गया. कोई उल्टे में घूम गया, पता नहीं क्या क्या कर लिया. उल्टे में घूम जाओगे तो बढ़ जाएगा पोटेंशियल. If you go against the electric field, so I start from here, go against the electric field, reach that point, the potential has increased. So it's meaningless. That E dot dl in this case is meaningless. So that is why we do not define potential for this kind of electric field, and therefore we call it non-conservative electric field. Okay? The electric field created due to changing B is non-conservative, and this is because that E dot dl on the full loop is not 0. For conservative this should be 0. That is the definition, that is the name. Conservative means the same potential is there. At one point, one potential, one nation, one exam. Right? So 1 point, 1 potential. So if you are making a loop and coming back to the same point, you should get back the same potential. Then you are it is a conservative field. But in this case, it's not. This is called non-conservative field. The field lines This is a field line. Tangent to the curve is showing the direction of electric field everywhere. That is the definition of field lines. So you have this field line. Now this field line does not start from a point and does not terminate at a point, like magnetic field. It's going in loops, closed curves. The electric field lines corresponding to this variety of electric field are closed loops. There is no starting point, there is no terminal point. Magnetic field also has this kind of lines. Okay. Then what else I had in mind? But if the electric field is created because of the charges, then from positive charge you start your lines and at negative charge you terminate those lines, right? So it's very clear demarcation. Although it is electric field, although the basic rule that force on a charge is force equal to charge times electric field vectors, that is obeyed by both kinds, right? But still the two are markedly different in character. One has closed lines, one has lines starting from one point terminating at other point. In one case you have E dot dl equal to 0 for any closed loop, in other case you don't have that, and so on and so forth, right? So this is the basis of this induced electric field. It's also called induced electric field. This is also called induced electric field. And how do I get the EMF? The EMF, by the way, this EMF is defined in a loop you are, or in a segment also. It is defined by the driving force per unit charge times dl. Correct. For battery also, or any emotional EMF. The EMF is defined by the driving force per unit charge dot dl. Now in equilibrium this turns out to be equal to that electric field created by the charge accumulation, and therefore it also becomes E dot dl. That's a separate story, but this is how it is defined. And therefore here in our case, now this driving force is genuinely Q times E. Okay. Now it's not equal to electric field. This electric field itself is the driving force, right? In the case of motional EMF, or in the case of batteries, others, we had a driving force which separated the charge, and that those charges created an electric field. Then we said that okay, since in equilibrium driving force must be equal to Q times E, so driving force divided by Q is equal to E. So whether I take this definition FD by Q, or I take E dot dl, they will give me the same magnitude. Okay. So this electric field is now equal to the driving force per unit charge. But the electric field that now I am talking, because of the changing magnetic field, itself is the driving force. It is not equal to E. It is not that driving force is separate, electric field is separate, and they are equal per unit charge. It is not that. This itself is the driving force. Okay, and therefore this E dot dl is your EMF. And that turns out to be minus d phi dt if it is a closed loop. And that is Faraday's law. This is Faraday's law.